We're going to talk about right triangle congruency. Got two objectives with this video. We're going to use special cases of triangle congruence postulates to determine if and how two right triangles are congruent. And we're going to understand the special cases of right triangle congruence and how they relate to triangle congruence postulates in general. It's a mouthful, but we'll get to it. We got HL over here, HA, LL, LA. What does all this mean? They're not city abbreviations. Sorry, Los Angeles. Okay, our first one is leg congruence. Okay, and I spoiled the reveal here. It's a special case of the side congruence postulate. Okay, so I have two right triangles. I got triangle XYZ and right triangle RST, and I have two pairs of congruent legs labeled. Well, we can use the Pythagorean theorem to find this third side. We got A, B, and C. And if these two in a right triangle, because we're using Pythagorean theorem, if I know A and B, C can only be one number. Likewise in the other triangle. So that's how I can say these two triangles are congruent. Now we got LA, leg angle. Okay, I have one pair of acute angles that are marked congruent. They're corresponding acute angles in both right triangles. And I have one corresponding pair of congruent legs. And that's all I need to show that these two right triangles are congruent. It is a special case of angle, side. We have two angles, an acute angle, a right angle, and a non-included side, which is a leg. It can also be a special case. Let's say this was the leg that was not marked, but it was this one here, ZY, and the corresponding leg, TS. That's a special case of angle, side, angle. I have the acute angle, a leg, and then the 90-degree angle with the leg included between the acute and 90-degree angles. Next, we have hypotenuse leg. The hypotenuse is marked congruent for both right triangles and a corresponding congruent leg. This is similar to the first congruence postulate we looked at, which was leg. I can use the Pythagorean theorem. If I don't know what B is, but I know A and C, I can solve for B, and it's going to be the same in both triangles. Therefore, those two triangles are congruent. This is also a special case of side. Our last one is hypotenuse angle. So I have my two triangles. Oops, I forgot to label them, didn't I? XYZ and RST. They're two right triangles, XYZ, triangle RST. And I have the acute angle labeled, the corresponding acute angles, and both hypotenuse labeled as congruent. That's all I need. It's hypotenuse angle. These two triangles are congruent. This is a special case of, you guessed it, angle, side. I have the 90 degrees angles. All 90-degree angles are congruent to each other. And then the corresponding pairs of acute angles are congruent, and the hypotenuses are congruent. Hypotenuses? Hypotenusi? Maybe it's like the animal moose, where plural is just the same word. Maybe it's hypotenuse, like hypotenuse. We're in Alaska. That's okay. Ignore the humor. So here's a little table. We got our right triangle congruences here on the left side, and we have our more general triangle congruences. So leg is a special case of side. Leg angle, oops. See, sometimes we just make small mistakes. Let's fix that, huh? We got leg angle. That's a special case of either angle, side, angle, or angle, side, depending on which leg is marked congruent. We have hypotenuse leg, which is a special case of side again. And we have hypotenuse angle, which is a special case of angle, side. So these are special cases of congruence postulates for right triangles. So to recap our objectives, use special cases of triangle congruence postulates to determine if and how two right triangles are congruent. And we showed a better understanding of those special cases of right triangle congruence and how they relate to triangle congruence postulates in general. Hope this video was helpful.